Hi everyone. Here I'm going to show you a demo about repeating measures ANOVA. This special kind of ANOVA is a little bit different from the normal ANOVA we used to run. So I'm going to give you a brief introduction. So like last time, the independent variables is the first thing we need to consider when we run repeated measure ANOVAs. So the same thing, the first thing about the independent variable type will be categorical independent variable. It could be gender, ethnicity, and the SCS, but pay attention because we are going to run repeat measures ANOVA. One of these categorical independent variable has to be a repeat measure variables. Of course, it can also include variables like not impede measured. So what is impede measured variable? Well, actually it's quite simple, straightforward. It's like for each level of this variable can be measured or can be observed within the same participant, within the same case. Such as longitudinal studies, we have to measure, like for example, academic achievement at age 3, 6, and 9 or 10, or we want to know the intelligence development from 3 months old to 12 months old. We have to measure a couple of times, but under the same participant, within the same participant. These are repeat measures. So in contrast to the normal independent variables, which is not repeat measures, such as gender, there's no way you can measure both females' performance and the male's performance within the same individual. This is impossible. So that's the differences between repeat measure variables and non-repeat measure variables. So usually by conducting repeat measures ANOVA, it can save us a lot of error, which can boost the power of the ANOVA dramatically, which will be a good way to try. And of course, in addition to the categorical independent variable, we can still have a continuous variables within this repeat measure ANOVA. But pay attention, continuous independent variables are always be non-repeat measured variables, which is to say, if you're going to run the repeat measures ANOVA, it has to be one of the independent variable. It has to be a categorical and repeat measure. Okay, let's go to the dependent variables. Of course, the same as normal ANOVA, it has to be a continuous one. That's easy. Okay, well, the next let's see under what circumstances we're going to use repeat measure ANOVA. So first, there's one way repeat measure ANOVA. It has to be have one independent variables. This independent variable has to be categorical and has to be repeat measures. Of course, it has to be more than 2 levels. And dependent variables has to be continuous. These are conditions. Here's an example. Does everyone feel equal happiness in the morning, noon, and evening? So here, the measure of happiness is our dependent variable. Let's assume this is a continuous variable. The independent variable is the 3 time point of a day, which is the morning, noon, and evening, which is possible for us to measure all the happiness scales within a same participant. So this can be a repeat measure independent variable, which makes this possible for us to run a repeat measures ANOVA for this test. Okay, let's move on to the more complicated situation, which will be a two-way ANOVA, which is like two-way repeat measures ANOVA. it has to be two independent variables. At least one of these independent variable has to be categorical. And at least one of these categorical independent variables has to be repeating measures. Well, this is awkward. Well, let's make it straight. That is, you have to have one categorical independent variable which is repeating measures. It doesn't matter for the rest one, for the other one. The other one can be a continuous like independent variable, or can be a categorical independent variable which is not repeating measures. It doesn't matter. Okay, dependent variable has to be continuous. Let's see a demo example. Here's whether female and male population have the same finger length of their second and fourth fingers. Let's say it's on your right hand, of your right hand. Okay, here we have two independent variables. One is gender, very straightforward. You see there are two levels, female and male, which is impossible to measure repeatedly within the same participant, right? Yeah. The other one is the fingers, which is the other independent variable. This can be repeat measures because everybody has their second and fourth fingers on their right hand. Well, I mean, generally speaking, right? And the dependent variables is the length of your fingers. Okay. All right. Here I'm going to show you some demos about the repeat measures ANOVA. Hello, everyone. Now in this demo, I'm going to show you repeated measures ANOVA. This is slightly different from the ANOVA that I just showed you. Here we go. So by running repeated measure ANOVA, one thing is very important for us is to see what's the difference between this ANOVA from the previous ANOVA, like we say normal ANOVA. Actually, the difference is just in the independent variable. To be exact, this is just in the categorical independent variable. So in repeated measure ANOVA, we will have at least one categorical independent variable which is repeated measures. The repeat measure will mean, the levels of this independent variable are measured within a same participant. Say, of course, here it is an example. Say, for infants, we care about the infant's vision development. So we measure each infant like vision acuity at 3, 6, and 9 months of age. 3, 6, 9 months of age. These are three different kind of levels. And these three levels are measured within the same participant. Then they give us a possibility to track the development of this particular baby or a group of babies. In contrast to repeat measure independent variable or repeat measure categorical variables, the other thing, like the other categorical, like normal categorical independent variable, like gender, like ethnicity, the level of such independent variables cannot be repeat measured within the same participant. Say gender, we have female and male, two levels. This is incredible to have a person, our participant, both have gender of male and gender of female. This is impossible. So that's the differences between the two kinds of categorical independent variables. And this also is the main differences between the normal ANOVA and the repeat measures ANOVA. Now I'm going to show you how to run this. Actually, it's quite straightforward. First, we go to Analyze in SPSS. Then generally in the model, which is the same place we run ANOVA. Instead of going to univariate, then we go to the third one, which is repeated measures. That's exactly what we're going to do. click here, then they will give us a little bit strange windows, which tells us for first is a within subject factor name. Well, in this case, we have to put the names of these repeated measures variables. Say, well, I'm going to show you first a one-way repeat measure ANOVA. Then we move on to the more two-way. Let's say we put the name of this repeat measure variables. What it is? Like say finger. Okay, I got the idea that I'm going to measure to test whether your left hand second, third, and fourth finger have the same length. Okay, here's our idea. Now we have 3 levels, of course. Now, once we click the number of the levels here and click add, then we create this repeated measure variables. Of course, you can click here, highlight it, then you can change the number of level, like change to 4, then click change, you're done. Of course, now this time we'll only have 3. Change. Okay, once we have done the repeat measure variable creation, or called definition, then we click define. This is a little slow. Okay, now it gives us a new window. Here, the first window on our right side will ask us for within subject variable. These are the name we have just designated, and there are 3 blanks that need us to fill in. Here we select what we want: the left hand, the second, fourth, third, and fourth. You can press the Control or Command button, then select all of them, then move them. There's something wrong. TS3. Oh, it seems we have to move one up the other. Okay, here we have done all the specifying which columns we need to be used in this ANOVA. Okay, now we have put all the correct levels in this window. The next thing before we clicking OK, we have to make sure the option things like normal ANOVA. We click this, and this, then continue, and click OK. Now we're ready to go. Okay, so here's our output window for us. So generally the model first, like before, it tells you the level of our independent variables, which we have 3 levels. Then the descriptive statistics tells you mean, standard deviation, and number of cases. Because it's a repeated measure, this n should be identical across 3 levels. Okay, multivariate test, we're going to ignore this because it's misleading. Then we move on to the next one. It's a test of a sphericity. This is important. This number, the significant value here, tells us the same thing as a Levin's test, which is whether we have the same variance between the three levels. If it's significant, that means the variance are significant different, which will make us make the result down here a little bit unreliable. Say, yeah, we're not lucky here. Now we have a significant value here, which means maybe we should be cautious to interpret the following results. But well, just let's move on. Okay, once you have done with this test of sphericity, then we move on to the next table, which is a very important thing to tell us what it is, what's the result of a testing, ANOVA testing. So here we can see there's a column, first column called source. Source means where are the effects came from. Here we only have one independent variable. That's, of course, that's the only way we can find our effects. So the next thing is a little bit weird because here SPSS give us 4 options, and each option tells you very, very similar things. And what we are going to do is just select one of them to report our results. But how to do the selection? This is a little bit like, well, it's up to you. But the first thing is very easy to understand. It's a sphericity assumed. That means if this table, the previous table, test of sphericity is not significant, then we can very, very confidently to report the first row results, which is like this. Degree of freedom is 2. Degree of freedom of arrow is 108, and F value is 110.960, and it's very well. It's significant, smaller than the 0.0001, and of course this is power of effect size, blah blah blah. Okay, but what if this test of sphericity is significant? Then if this one is significant, then we, instead of looking at the first row, which is a sphericity assumed, we can choose any one of the rest of 3 rows to report our result. Any one is like they do some adjustments of the degree of freedom, which gives you a more robust results, which can more reliable than the first row, because we don't have equal variance across these 3 levels. So this is a rule of thumb. If test of sphericity is significant, then we are going to choose one of these 3, the second, third, and fourth row, to report our result. If this test of sphericity is not significant, then we might as well just report the first row. Is that clear? And don't forget, I say report the first row. You have to pay attention. The first row of finger at the same time the first row of arrow. If you are going to report the second row, make sure both finger and arrow, the value has to be reported of the second row. You know what I mean? Okay, here's the the rest will be like very detailed comparisons that you can look at for your report. Now I'm going to show you how to run a 2-way repeat ANOVA. Well, the same thing. Let's go to repeat measures. Okay, here we already have this factor. Now this time I'm going to very interested in like whether left and the right hand have the same length of these 3 fingers. Then I put hand, and because we usually have 2 hands, then just 2 levels, add. Okay, we're done. Then define. Okay. Yeah. Now since we already have like the fingers of left hand, here you can see now we have 2 within subject variables, which is the repeated measure variables. One is finger, and the first one is finger, and the second one is hand. You can see there are 2 number index to indicate what you are going to put. So there's a 1, 1, 2, 2, 3, 3. That means this is the level of the first variable, which will be second, second finger, third finger, and fourth finger. And the second variable is hand. We have two levels, which will be 1, 2, 1, 2, 1, 2. 1 should be, let's say, left hand, 2 should be right hand. So the first row, we're going to move left hand, second finger into here. And the second one should be right hand, second finger goes to here. Oh, that takes some time. I think you can drag. Just drag and drop. Yes. Now next right hand and fourth hand and fourth finger and fourth finger of your right hand. Okay, this is the left, right, left, right, left, right, and 2, 2, 3, 3, 4, 4. Okay, it's perfect. And of course, we need to check the option. Now we have interaction, and we move everything to the right, everything the same, stay the same here. Okay, then we click OK. Okay, let's see what's going on. The first one tells you the variables. We have fingers with 3 level, hands with 2 level, and what are these column names for each variable combination. Here is a descriptive statistics, mean, standard deviation, and case number cases. We're going to ignore the third table, move to the severity, and like last time, severity test will be shown the significant result of a finger because like whatever. That means the test of severity failed. Then we move on to the next table, which tells you the main fact and the interactions of each factor. Okay, here we first look at the finger, which is our main fact, and the arrow of this finger. Okay, finger will show there are significant differences, degree of freedom is 2. If you prefer looking at the second row, yeah, this is the degree of freedom with and significant level. This is the arrow row. And now is the hand. This is not significant. Left hand and right hand, there are no significance. This is a degree of freedom, arrow. And one thing you need to look at this is in repeated measure ANOVAs, each factor, each effect goes with an arrow item. It's not like the normal ANOVA. We only have one arrow item. Here, each effect has an arrow item. Like main effect, like interaction, we all have this arrow item. When you report the result, make sure your degree of freedom, the first one and second one came from the same factor. Like if you report the main fact of finger, this is the first degree of freedom, and the 108 is the second degree of freedom. But if you're going to report the second main fact, the main fact of hand, which is our second variables, the first degree of freedom is 1. The second degree of freedom is 45, which is next, right after it. That's the thing you really need to be careful when you report the results. Okay, the third one, the interaction, it shows not significant. Of course, it shouldn't be, right? Okay, that's it for our two-way ANOVA with 2 continuous variables. But say some people will ask, what about we have one continuous variable in our repeat measure ANOVA? Let me show it to you. Say we only have hands, this one single categorical independent variable. then as I said, all the continuous variables are between subject variables. Say age, say okay, whatever. Okay. Now, what I'm going to put into this covariate, which is the continuous independent variable, I can say let's put the hand circumferences down here. Okay, make sure we double check the model. If we have continuous independent variable, we always check this model. Okay, let's do here. Now, in this window, a little bit different from what we have last time. Okay, but what we're going to do is the same. Main fact goes to right, main fact goes to right, and here you found this is unable to select the interaction. They'll give you an error, but don't worry, just leave it alone and check the option. Go to here. Okay, continue. Okay, I'm going to show you is once you have a repeat measure variable, once you are running a repeat measure ANOVA, SPSS will automatically give you the interaction between the continuous variable and your categorical variable, which is like this. You can see here, right? Now here, this is a little bit strange because we only have two effects. One is handness. Oh, sorry, one is hand. The other is hand and the hand circumferences interaction. Well, both of them are significant. Wow, it's surprising. Where is the circumferences? The main factor, hand circumferences, is, don't worry, it's just right here. So pay attention. The reason why we cannot find hand circumferences main factor in this table, because this is a table just for within subject effects, which is repeat measure independent variables effect. Because the continuous independent variable is between subject variable, independent variable, the effect can only be found down here. It's test of between subject effect. Now you found this hand circumferences is here, which is also significant. Wow, it's really nice. Yes. Okay. You'll see here, once you report it, you're going to report these two effects. But don't forget the hand circumferences effect, because once you run two-way ANOVA, no matter it's between subject ANOVA or repeat measure ANOVA, these ANOVA, two-way ANOVA, always have three sources effect, which will be two main effect and one interaction between these two independent variables. Okay, hope you can understand how to run ANOVAs in SPSS, and just to let you know, if you have any question, you can email me. You know my email address, right? Okay, have a good day.